So today we will learn about the waterfall model. So what is the waterfall model and what is the terminology behind this waterfall model, right? So let's directly go to the slides. So if you see, as you can see, waterfall model. The waterfall model was the first process model to be introduced. So we'll see what is a process model is. So imagine you are going to make a cup of tea, right? So in that case, you should first gather the ingredients, boil water, and measure or decide the count, and gather cups and saucers and spoons. Likewise, you should have some basic necessities to do it, and you should think about the supplies, the sugar, tea dust, and milk powder. Likewise, right? So then you will first boil water, then mix the ingredients, and then serve. So it's a process. It's a linear process, right? So in the mid of the process, you are not going to think about something else and change your mind and just throw the tea or milk tea you have prepared, and not you are not going to start making coffee, right? Because your aim is to make tea with milk or not, right? So here we call the waterfall model as the linear or sequential life cycle model. Linear or sequential life cycle model, and it's very simple to understand and use, right? Let's see whether it's true for you, right? And in waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. It means this is a linear process. Step 1, 2, 3, 4, 5, likewise, right? So you can't do the step 2 without completing step 1, right? So you can't do the step 3 without completing step 2. 1, 2, 3, 4. Likewise, it's in an order, and you can't skip any step. You should do all the steps, and you can't repeat them. Most importantly, you can't repeat them. And to proceed to the next step, you should first complete the previous step. The waterfall model is the earliest SDLC approach that was used for software development. It is applied for almost every development task, and maybe organizing. When you are organizing something also, you can apply this one, right? So we are talking it for the software development specifically. The waterfall model illustrates the software development process in a linear sequential flow. Linear means it's a line, so it's straight flow, right? Straight way. This means that any phase in the development process begins only if the previous phase is completed, right? So I have talked about that. Waterfall model design. So here waterfall approach was first SDLC model to be used widely in the software engineering to ensure success of the project. So why we are following these models? Because in order to make the software successful, or in order to make something successful, we should have a terminology, right? So think about the 3R concept, right? So there's a terminology, right? Reduce, reuse, recycle, right? So think about the S5 concept, right? So there's a terminology, right? And think about the goal setting: SMART, specific, measurable, achievable, realistic, and it should be completed in a time frame. So it's a terminology. Why it is there? It is there to enhance your productivity, right? To make something special, make something achievable, right? So that's why it's there, right? And so in this waterfall model, typically the outcome of one phase acts as the input of the next phase. So what it says? It means, so here we have first step, right? So you are completing first step, and here we have the second step, right? So it is waiting for the output of the first step, right? So first step is going to deliver its output as the input of the second step. So it will grab it like this, right? So now second step is processing, and third step is waiting, right? So after completing the third phase, it's going to give that output as the input of the third one, right? Again repeating, right? Fourth step is waiting, third step output is going to be given as the fourth step input. Likewise, it's going to proceed like this, right? So in the last phase, you have a finished project, right? And you are not going to repeat, right? You are not going to again go back and go to the first step and tell I have forgotten something. Can you do it? No, you can't do it, right? It's a linear process, right? So these are the this is the graphical representation. So it is similar like the SDLC one. So let me zoom in and show you. I think I can zoom. No, right. So let me right. So this is the graphical representation, right? Can you remember the 6 phases? Requirement analysis, system design or just design, implementation, testing, deployment and maintenance, right? 6 steps, right? So first gather requirements, then design. So in the design you will think about the scope and you will narrow down the requirements because you can't make a universal application, right? So you should narrow down the requirements, right? So in the design phase you will do that, right? Then implementation, you will code, right? You will code requirement analysis, then system design, then you are going to code it, and then what? Then do a test, right? Then do a test, then what? Then you are going to deploy it to the internet, or maybe in the deployment you are going to give the necessary training for the user. So imagine you are going to make a lecture room booking system for SIBA, right? But the lecturers are not aware about that, and also so do the students. But it's in the web, right? But it's not a good deployment. You should do a webinar or a awareness session and tell the students and lecturers how to use it, how important it is. Likewise, you should do it. And what about the maintenance phase? So students are complaining, right? They are saying loading time is too much and we can't see it clearly. The font is really small. Likewise, so then you will say, okay, please bear. In the next update, we will fix those bugs or things, right? The things we need to improve, right? So then you will upgrade the website and increase the font size. Likewise, so it's going to be in the maintenance. And sometimes they will give new requirements. Then you can add them and update the website. So that's called the maintenance. But remember, in waterfall model, once you have delivered the product, you are not going to again come back and repeat these things, right? So you are not going to again do testing. You are not going to again coding, right? You are not going to come back to the previous steps, right? That's why it's shown like this here. Can you see it's a linear one here? After requirements analysis, it's going to go here, system design. After system design, it's going to go here, implementation. Then it's going to go here, testing. Then for the deployment, then maintenance. Can you see a reverse arrow or repeating arrow here? No, here. Can you see the arrowhead? So if you Google it, you can get a very clear image. So here, it's only pointed forward. It means it's a linear approach. It's like a staircase. It's like steps. First step, second step, likewise, right? But you can't come back, right? So that's the main idea around the waterfall model. So here it says requirement gathering. So we have discussed these things, right? SDLC. Requirement gathering and analysis. All possible requirements of the system to be developed are captured in this phase and documented in a requirement specification document, right? So imagine, as a typical example, we can get a trip, right? So when you are going a trip, you should list down all the requirements. Where are you going to stay? How many places you are going to visit? What is the mode of travel? What is your average budget? What is the meal plan? How are you going to lodge? Accommodation, safety. Likewise, you should first prepare a document. So here there's a special term for this. We call it as the SRS, right? Software Requirement Specification, SRS document, right? Or software or system requirements specification document, right? So you will first document it. Then what? Then you are going to do the system design. So in the system design, requirements will be refined. The requirement specification from first phase are studied in this phase. You will thoroughly evaluate these things. This system design helps in specifying hardware and system requirements and helps in defining the overall system architecture. So once you have documented all the requirements, you can think, is it going to be a feasible project, or is it going to be achievable or not? Is it realistic or not? Otherwise you won't, because many people have different opinions. That's why. So it's important to document. And the implementation. So generally implementation phase is the largest or very time consuming phase, most time consuming phase in the development, because you can easily document but you should practically implement it, right? So implementation means development with inputs from the system design. Why it is important? Why it says with inputs from the system design? Because we are following the waterfall model. So in that case, the output from one step is going to be an input for the second one. That is not going to reverse, right? It's not happening like this, only this way, right? Only this way. With inputs from the system design, the system is first developed in a small program called units, right? So we will, imagine you are going to develop a product, some maybe it's some food dough, maybe a design, maybe a bookmark, maybe even a book, right? So first you are going to produce it in small amounts. So if you are planning to make a ton of toffees, you first need to develop 100 toffees and get the opinions of others. You should test the things. You should do a market analysis, right? So here also we are doing that. This is regarding the software. We will do a small development, and we are developing units which are integrated in the next phase. Integrating means we are going to connect unit by unit. It's like a chain, right? Chain by chain, loop by loop. Each unit is developed and tested for its functionality, which is referred to as unit testing. Testing unit means unit testing, right? So don't you see a familiarity with that term, unit testing? Why, you had a unit test last week, right? So it's about this, right? Unit testing means what? So when it comes to our lectures, we will teach some little thing, you will explore it, and from that small unit we are going to evaluate yourself. That's called the unit test, right? Unit testing, right? Makes sense. So here in software also, first you will develop a small part, then regarding that we are going to thoroughly do tests. And here we have some kind of testing. So one type of testing is unit testing, and there's another thing called integration and testing. All the units developed in the implementation phase are integrated to a system after testing each and every unit. It means, so as I said, the software is like a huge chain and units are loops, small loops in the chain. So after thorough testing, we are going to interconnect loops. That's it. That's the idea behind this. Integration means interconnecting. Then after connecting all loops, you can again do a testing, right? So deployment of system. Once the function and non-functional testing is done, the product is deployed in the customer environment or released into the market. So after doing all the tests, the product or the software is going to be deployed to the market or delivered to the customer. Then the last phase, maintenance. There are some issues which come up in the client environment. So when the client is running the product, there may be some issues. So then you can fix it, right? To fix those issues, patches are released. Patches means updates, right? It's like your mobile phone, it's like your laptop, computer, right? Because they are giving continuous updates. Also, to enhance the product, some better versions are released. It means updates. It's about the updates. Maintenance is done to deliver these changes in the customer environment, right? Now you are not going to make a prototype. You directly do changes in the real system. Directly do changes in the real system. So now let's see what are the advantages of waterfall model. Simple and easy to understand and use. Is it correct? Yes, simple, right? First gather the requirements, then design, implement, test, deploy, and do maintenance. You don't need to go back and again do the designing, again do the testing. You don't need to do such things. So it's very simple, simple to remember even. Easy to manage due to the rigidity of the model. Rigid means it's hard. Rigid means hard. Hard means not difficult. Hard means it's fixed. It's fixed. So if we take this one, the shape is fixed. I can't amputate it, right? It's fixed. So I can't call this as a table because the name is fixed and it's chair, right? Here we have clearly defined stages. So here we have only 6 stages, so they are well defined and also works well for small projects. Why it is working for smaller projects? Because in bigger projects, so if you think of a complex project, we can't use it. What is the problem? Because requirements are going to change time to time. So imagine we are developing an app or something for 2 people. It's easy. We can arrange 2 meetings. We can arrange direct meetings with them and gather their requirements. And they are mostly going to be fixed requirements because they are only 2. Imagine you are going to develop an application for 1,000 people. So we can't meet them in real life sometimes, right? We can only get some opinions. So in the mid of the development, sometimes they will say, yes. So in that case, we should gather many requirements and sometimes people won't share their opinions until you deploy the product. So after you developed and give them to use, then they will start to give their opinion. So in that case, it's not recommended to use the waterfall model because you can't do updates here because the requirements are fixed, and once you have deployed or send the product, you can't do alterations. That's why it says it works well for smaller projects. Well understood milestones. So as I mentioned, one step, after completing one step, that the output from that step is going to be fed as the input for the other step. So likewise, so you have a clear goal. First do the requirements, document the requirements, then define the requirements and understand your scope, your limits, then do the development, then do the testing, deployment and maintenance. That's it, that's finished. Now again you don't need to go back to the requirement gathering and do requirements again, gather requirements again. No development again, fixed and finished. Easy to arrange tasks. It means you have only 6 phases. It's easy to arrange tasks. That's correct. Because you have only 6 phases. 6, right? That's right. Applications. Applications means the usages of this waterfall model. Some situations where the use of waterfall model is most appropriate are requirements are well documented, clear and fixed. Here, in order to use the waterfall model, requirements should be fixed. Why is that? Because this is not flexible. You can't change the code or the requirement in the mid of the development. Product definition is stable. It means you know about the end product. The end product won't have any extra features and it won't miss any features because you have first documented. You have documented 5 requirements and that is fixed. So the end product will have only 5, no 6, no 4. Only 5, only 5. So you are going to develop a chair. So first you decide this chair is going to have 4 legs. After the development, if there are only 3 legs, it means it's your fault. But if it is going to have 5 legs, it's also your fault, because first you have defined you are going to have only 4 legs. That's why. There are no ambiguous requirements, and ambiguous means anonymous requirements, because once you documented the things, no one can tell you to add any extra feature, right? So can you remember the trip planning app we were discussing about? So if you are going to make a app to plan trips, that's only for planning trips. We are not going to integrate payment methods there. You can't pay using that app. If someone says I need to have a payment gateway in your app, no, you can straightforward tell no. Why is that? Because you are following the waterfall model. You are following the waterfall model. So in that case, you can't add extra requirements there. So it's fixed. No anonymous or no ambiguous requirements. Ample resources with required expertise are available to support the product. It means when you follow such rigid or fixed steps, you know what is your limit and whether it's achievable or not, right? So it's easy, right? It's easy to do things, work with this. The project is short and sweet. Why is that? Only 6 steps, requirements are fixed, and it's easy to progress, right? Because the thing is fixed requirements, fixed time, and it's easy to work. And we have disadvantages as well. No working software is produced until late during the life cycle. It means here during the requirement gathering, can we see the end result? No. During the design, can we see the end result? No. During the development, we can see a result, but it's not the end result, because you have several other phases, right? Several other phases, and high amounts of risk and uncertainty. It means maybe you are planning to deploy a website, but the thing is now it's demanded. So think about the AI revolution. So those days it was a great hype. So all of most of the students and most of the organizations were promoting AI short courses and related things. But what happens now is, now the trend has gone down. So imagine you have started to develop a website for AI learning, right? And will it be sellable, or can we promote it these days easily? No, because that hype has gone down. It's declined, right? That's about the trend. Another example. So during the COVID season and during that power cut season, the coconut shell fueled coconut shell fueled stoves or cookers were popular, right? So imagine you are planning to make a company for producing such things, right? But now the trend has gone. So if you have invested there, and if you were planning to deploy or planning to finish the project by 2026, now in the mid of the development process you realize aparadi, right? So that's what it is saying about, right? Here high amounts of risk and uncertainty, right? So it's not certain, you have a risk, because working software is not produced until the end of the phases, right? End of the phases it's not produced, that's why. So keep those things in your mind. Not a good model for complex and object oriented projects. So just don't think about this object oriented thing now. If we had the time, we will talk about that. Just remember, not good for complex projects. So as I mentioned, it's good for 2 or 3 people, because they will only have limited requirements. But if it is going to be approached to thousands, millions of people, there are complex requirements, but you can't accommodate it here because this is not flexible, this is fixed. Poor model for long and ongoing projects. That's what I talk about, those two examples. If it is going to take 5 years, the requirements would have been changed at the end of the 5 years, right? But if it is for a short period like 1 year, 6 months, it's fine, because the trend will be there, and you can rapidly develop and stop the project. Not suitable for the projects where requirements are at a moderate to high risk of changing. If the requirements are changing, keep that word, mark my word. If the requirements are changing and there's a high risk of changing, you can't use it. And also some disadvantages. It is difficult to measure progress within stages, because you can't assume it is finished clearly, because the product will be delivered at the end of 6 phases. In the mid, you can't assess it whether you are going to success or not. Cannot accommodate change in requirements, I have mentioned. Adjusting scope during the life cycle can end a project. So first you have planning to deploy or make an app for 5 people. Now in the mid, the investor is saying no, we should expand it up to 100 people. So now you have by developers, and you have already designed interfaces and stuff. And in the mid, if they are saying like that, you should end that project and start again, gather requirements for 100 people, and you should collect resources to accommodate 100 people. It's like this. So earlier, if we were intended to accommodate 20 students here in this lecture room, after finishing this, after constructing this, if someone asks to expand it up to 200 people, is it feasible? No. We should knock down these columns, we should knock down that wall there, and we should cut down that coconut tree also, because likewise it's not feasible, right? So that's why it's saying, if the scope is going to change, we should end that project and start another project again. So now the project name has to be changed to accommodate 100 people. Integration is done as a big bang at the very end, which doesn't allow identify any technological or business bottleneck or challenges early. Integration is done as a big bang at the very end, which doesn't allow identifying any technological or business bottleneck or challenges early. It means you can't experience the actual project or product until the end. So if there's a defect, you can't detect it early, because you can only experience the product at the end. And also, during the development, you are not going to test. So in that case, there's a high risk to miss errors, because you are waiting until the deadline, until the last phase you are waiting. So that's about the waterfall model. I hope you understand. So you can know more information using the internet.